Good morning, students. This is virtual class of physics class 12th. In today's video, we will solve some numeric problems of the chapter Nuclear Energy. First numerical is given that two stable isotopes of lithium 6Li3, you can see this question, 6Li3 and 7Li3 have respective abundance of 7.5% and 92.5%. These isotopes have masses 6.01512 unit and 7.01600 unit respectively. Find the atomic masses of lithium. To solve this question, we will use a formula of ratio, then find the average mass A average equal to ratio of first isotope multiplied by mass of the isotope plus ratio of second isotope into mass of second isotope divided by sum of the ratio, means P1 plus P2. So put the value and get the answer. What is the value of P1 is given? Ratio of first isotope 7.5%, means 7.5 multiplied by mass of first isotope is given 6.01512 plus ratio of second isotope 92.5 multiplied by mass of second isotope 7.01600 divided by sum of the ratio 7.5% plus 92.5%. After solving, we will get 6.941 unit. This is the answer. Average mass of the lithium. This is the first part of the question, and in second part of the question you can see boron has two stable isotopes, 10 boron 5 and 11 boron 5. Their respective masses are 10.01294 unit and 11.00931 unit, and the atomic masses of boron is 10.811 unit. Find the abundance of 10 boron 5 and 11 boron 5. Means in this part we have to find the ratio of the isotopes. So similar formula will be used in this part, so you can solve in your homework. Now next part, next question 13.2 is given. Three stable isotopes of neon 20, neon 10, 21 neon 10, this question, and third 22 neon 10 have respective abundance of 90.51%, 0.27% and 9.22%. The atomic masses of three isotopes are 19.99 unit, 20.99 unit and 21.99 unit respectively. Obtain the average atomic masses of neon. So again the similar formula will be used. Look, average mass or average atomic mass will be ratio of first isotope is given 90.51%, 90.51 multiplied by mass of this isotope is given 19.99, 19.99 plus second ratio of second isotope is given 0.27, 0.27% multiplied by mass of second isotope 20.99 unit plus ratio of third isotope is given 9.22 multiplied by mass of third isotope is given 21.99, 21.99 divided by sum of the ratio means 90.51 plus 0.27 plus 9.22, and after solving we will get 1809.29 plus 5.67 plus 202.75 whole divided by 100, and this will give 20.18 unit. This will be average mass of the neon. Now, next question. Next question is given. Question number 13.3. Obtain the binding energy in million electron volt of a nitrogen nucleus 14 nitrogen 7, given mass of the nucleus is 14.00307 unit. In this question, we will use this formula. Binding energy delta E is given by delta M multiplied by 931.5 million electron volt. By this formula, we can calculate binding energy in million electron volt, where delta M is mass defect. Delta M equal to mass defect. So, how can we calculate the mass defect? To calculate the mass defect, formula is used. Delta M equal to mass of nucleons, mass of nucleons minus mass of the nucleus, mass of nucleus. Mass of the nucleus. So first of all, we will calculate mass defect. Total mass of nucleon will be total number of nucleons, means total number of protons plus number of protons multiplied by mass of proton plus number of neutrons multiplied by mass of one neutron minus mass of the nucleus. Here, number of protons in nitrogen, you can see in nitrogen number of protons equal to 7. So 7 multiplied by mass of proton is given in starting mass of proton is given NCERT exercise. You can see here some constants are given, and in your board examination mass of proton will be given. Mass of proton, you can see mass of hydrogen atom equal to mass of proton 1.007825 unit. So mass defect will be total number of protons 7 multiplied by 1.007825 plus mass of neutrons, number of neutrons in nitrogen. Number of neutrons will be 14 minus 7 means 7. 14 minus 7, 14 is the mass number of nitrogen and 7 is the number of protons. So number of neutrons will be 14 minus 7 multiplied by here mass of neutron is given 1.008665 8665 unit minus mass of the nucleus of nitrogen was given 14.00307 00307, and you can easily calculate delta M will be 14.1155 minus 14.00307 unit, and this will give the mass defect 0.11243 unit. Now binding energy will be, in this question binding energy will be delta E will be mass defect 0.11243 multiplied by 931.5. This will give 104 104.73 million electron volt or mega electron volt. This will be the answer. Now question number 13.4. In this question, given the obtain the binding energy of nuclei 56, iron 26 and 209, bismuth 83 in units of million electron volt from the following data. Data is also given. Mass of the nucleus iron is given 55.93499939 unit. This mass of bismuth is given 208.980388 unit. You have to calculate binding energy again by using formula of binding energy equal to delta M multiplied by 931.5. This formula will give the binding energy in million electron volt. So you can solve this question as earlier. Now question number 13.5. Before solving numerical number 13.5, consider about problem number 13.4. It has been discussed that how to calculate binding energy per nucleon using by formula delta E equal to delta M multiplied by 931.5 or near about 931 million electron volt. But if we want to calculate binding energy per nucleon, means delta E upon A, then we will divide whole the equation by the mass number of the nucleus. Suppose that for 56 iron 26 binding energy is obtained 492.26 million electron volt. Then to obtain binding energy per nucleon, it should be divided by the mass number of iron, which is 56, and it will get 8.79 million electron volt per nucleon in salt per nucleon. Similarly, binding energy per nucleon for bismuth atom delta E upon A will be binding energy related to bismuth nucleus, which will be obtained as 1640.26 million electron volt divided by the mass number of bismuth, which is given 209, and it will give 7.848 million electron volt per nucleon, in short Nu. Now question number 13.5. In this question we have to calculate binding energy in 3 gram mass of the coin of copper. So first of all we will calculate binding energy in 1 atom of copper. So First of all, we will calculate delta M, which will be total mass of nucleons of copper minus minus mass of copper nucleus. So number of protons in copper is 29 multiplied by mass of proton plus how many numbers of neutrons in copper. You can see 63 minus 29 multiplied by mass of one neutron minus mass of the nucleus, which is equal to 29 multiplied by mass of one proton 1.00783 plus 63 minus 29 means 34 multiplied by mass of neutron is 1.00867 and minus mass of nucleus, which is given, you can see 62 point minus this figure, eight six seven minus this figure, you can see minus this figure, we will get 0.59 225 unit. This is the mass defect in the given nucleus. Now we will calculate binding energy by using this formula. Delta E equal to mass defect, which is obtained 0.592225 unit multiplied by 931 in round figure. It will give 551.385 million electron volt. Now total number of atoms in 3 gram of copper. It is needed to calculate how many numbers of atoms in 3 gram of copper. You know that 63 63 gram copper consists 6.02 into 10 to the power 23 atoms. So 3 gram of copper will consist the number of atoms equal to 6.02 multiplied by 10 to the power 23 multiplied by 3 upon 63. It will give the total number of atoms in 3 gram of copper 2.87 into 10 to the power 22. So binding energy of these atoms will be delta E equal to 2.87 into 10 to the power 22 multiplied by binding energy of one atom of copper, which has been calculated as 551.385, which will give 1.6 into 10 to the power 25 million electron volt. So these are some numeric problems related to mass defects and binding energy. In our next video, we will discuss about some topics of semiconductor devices. Till then, keep watching. Thank you.